This is the second video in the series covering the Alpha Anywhere punch list app. If you haven't watched the overview video that describes this app's functionality, you should do that before watching this video. This video is aimed at intermediate to advanced developers who are familiar with developing mobile apps with Alpha Anywhere. I'm not going to cover each step, however, I will try to explain some of the more advanced techniques I used to build the app. Rather than trying to cover everything in one video, I'll be building a series of videos that explain in detail how certain features were implemented. In this video, we'll take a look at the basic component structure and component initialization. I'll share some tips and techniques that I've developed over the years that you may find beneficial when creating your own components. This is a PhoneGap app, and like all PhoneGap apps that you will build with Alpha Anywhere, I'll be using the integrated PhoneGap app builder to build and install the app on an Android tablet and an iPhone 6 to demonstrate the cross-platform functionality. Here I've opened the component in the Alpha UX builder, and I've collapsed all the panel cards so that it's easy to understand the app structure. This app uses a top-level programmatic panel navigator that contains all the panel cards and a panel layout with a second panel navigator. The first three panel cards contain the parent, child, and grandchild lists that are bound to the MySql database. All of the lists will persist their data and media files to the device's local file system for offline use and updating. When online, the media files will be stored in an S3 bucket and the data is synchronized to a MySql database. Let's start out by taking a look at the structure of the database. I'll be using Navicat to work with the MySql Project DB database. There are 5 tables associated with this app. The projects table is the parent table, and it contains all the information about specific projects. If you look at the table structure, you'll see an auto-incrementing integer that is the primary key, and other fields that include the project name, address, owner's contact info, etc. The punch list items table also contains an auto-incrementing integer primary key called punch list _ID, and a project _ID field that is used to establish the child relationship between the punch list items table and the projects table. Other fields include the punch list item category, status, description, start and end date, and fields for the photo file name and the audio file name. I've chosen to store all the media assets for this app in the cloud using an Amazon S3 bucket. This structure allows the project to have a one-to-many relationship with the punch list items table so that a project can contain many punch list items. The punch list details table also contains an auto-incrementing integer primary key called punch list _detail _ID and a punch list list item _ID that is used to establish the child relationship between the punch list details table and the punch list items table, effectively making the punch list details table a grandchild of the projects table. The punch list details table includes a date field, a notes field, and an audio notes field. This structure allows the punch list details table to have a one-to-many relationship with the punch list items table, so a punch list item can have many notes and recordings. As you'll see, Alpha Anywhere makes working with this type of database structure very easy because a list can be designated as a child of another list. The other 2 tables that you see here are categories and status. Categories contains all the categories that a punch list item may be assigned to, and the status table includes all the status tags that a punch list item can be assigned. The data from these tables will be stored in a client-side data cache on the device, and the default values will be provided just in case the server is not available when the app is first installed and used. The data in either of these tables may be changed, and the client-side data cache will be refreshed every time the app is launched and the server is available. You'll notice that I'm storing the values from these tables within the punch list items table, so my database is not technically normalized. In this case, I don't think data normalization is required. I've tried to make the structure and the data as simple as possible. As always, there are a lot of options for building an app. I've chosen to use a panel navigator that includes 3 panel cards and 2 panel layouts. The second panel layout is used to display the editor control bar and the numerous editors, along with some associated panel cards that contain the form view controls that will use the editors. This is done in place of the detail view, which you may be more familiar with. There are also 2 injectable content containers that are used for search within a control bar disclosure. When I started building this component, I started out with a panel navigator and 3 panel cards, each containing a list. I pre-populated the database tables with some sample data that I could use to display in the list. This helped to establish the flow of the app. I found that it's best to start out with some simple functionality and to build off of that. Each time I made a major change, I would save the component with a new name. I like to use sequential numbers. I started out with prototype number 1 and ended with prototype number 56, which became the finished app. Let's take a quick look at prototype 5. You'll see 2 panel cards and a data-bound list in each of them. The third panel card is the more complicated one. Here we can see an editor set and a few editors, and the first use of a form view control that will use the editors. If I run the component, you'll start to get a feel of the application flow. You'll notice I didn't worry too much about the look of things at this point. I'm more concerned with flow. The process of building an app like this is a creative and iterative one. The way it feels and flows is important, and with a tool like Alpha Anywhere, it's easy to try a lot of different things and get the app and the application flow just right. Here's the final rendition of the component. If we expand the panel card main and its nested containers, you'll see the panel card contains a header and footer section, each containing a control bar and a list. In this case, list underbar projects, which is the parent list. The list is populated by a SQL data source, which is populated by the projects table. The connection string name I've used is projects DB. If you used a different name for your connection string, you'll have to make that change here as well as for the other lists that are used within this component. If we look at the list properties, you'll see that has detail view is checked, has search part is checked, and data is persisted to the file system. If we look at the detail view properties, you'll notice that there isn't a detail view field map. That's because we'll be using a form view control for the detail view. Since this is the parent list, it's important to set the properties for the media and other linked files, since these settings will also be applied to all the child lists. In this case, I've chosen to upload to S3. You'll need to modify the Amazon S3 storage connection string if you used a different name. Since I wanted a custom behavior that follows a pattern used by many iOS apps, that's swiping a list row to reveal a couple of buttons to edit or delete the record, I wrote the JavaScript and CSS required to implement this functionality for this app. We'll probably add this to the list builder in the future, but I think it's important for you to realize that you can add your own functionality to almost all of the controls. If you look at the list events, you'll notice I'm calling some custom JavaScript functions to handle the row swipe events, and the onClick event updates a few of the control bar data variables before closing all open rows and activating the panel card that contains the punch list items for the project. You can view most of the custom JavaScript functions used within this component by selecting Code, JavaScript Functions. You'll notice very little use of Action JavaScript in this component. That's because quite often I'll use Action JavaScript to generate the code, then I'll copy and paste the generated code into a function that I call directly. It's less overhead and keeps my JavaScript in one place. In this example, let's say I want to refresh the data in one of the lists. I'll open up the JavaScript Actions editor and add a new dummy action, one that I'm going to delete when I'm through. I'll call it foo. I'll then edit the action. Add a new action using Action JavaScript and filter the Action JavaScript on List, selecting the list control actions. Then I'll select Refresh Data and select the list that I'm interested in. In this case, I only want to do an incremental refresh, so I'll check that option and then click OK. Then I'll click View JavaScript and copy and paste the generated code into my own function, and then I'll call it as I need it. When I'm done, I'll cancel and then delete the action foo. Let's talk about component initialization, and to do that, let's look at the client-side events. For almost every app I build, I create my own global object. In this case, I've called it this app, and it is instantiated in the client-side onInitializeBegin event. I used to attach this object to the alpha dialog object, but I found that I have more flexibility by defining my own global object because it's always going to be available even when the component uses a nested component. The global ThisApp object is used to contain all the properties that I may need at any time in the app. It's a convenient place to store state flags, global properties, etc. And since I'm only creating one global object, I'm not polluting the global JavaScript namespace. Another important event is the onPhoneGapReady event. This event fires in a PhoneGap app after all the PhoneGap code and plugins are installed and in a stable state. It only fires once. It always fires after the onRenderComplete event. Since I'm using the status bar plugin to adjust the panel object size to allow the status bar to appear above the panel card, I need to make sure the plugin is installed and ready for use. You'll also notice that I'm resizing the panel object in a set timeout function with a 100 millisecond delay. Often this is required to allow the DOM time to settle before making any adjustments. So remember, anytime you need to call a PhoneGap plugin on component initialization, the onPhoneGapReady event is where you want to do that. We've covered a lot of ground in this first technical video of the project punch list component. In the next video, I'll discuss the control bars and the form view controls, so keep an eye out for that. Thanks for watching, and I hope you learned a few things that you can put to good use with Alpha Anywhere.